DigitalituM podcast at the intersection of manufacturing and digital transformation. Today we have a special session with Holger Schlaps with SULZER and Steve Forrest with AutoTools as we talk about manufacturing and the future of AI. We had recently a panelist at the GACC SME Conference in Greenville a couple of weeks ago, where the three of us already talked in a session, and we are recreating this session here and share it to the public. Holger, would you mind started and introduce yourself?
Yeah, so first of all, thank you, Markus, for this possibility. So my name is Holger Schlaps. I'm from SULZER. Currently, I'm in Munich, actually. So from Germany. And so what we are doing, SULZER is an IT service provider doing projects all over the world. And we started in Germany, but we are located in the whole world. And we do AI actually since 2018. So we started very early. And this is why I'm here. I'm head of research and development and also AI. And so AI is always a great topic. So great to be here.
Good. And you guys actually worked on AI when AI wasn't even a thing and people in general didn't know really what this thing is actually all about.
Yeah, so it was a long time before end of 2022 when ChatGPT entered the world and changed the media and everyone was talking about it. So I'm focusing on AI since 2018 and we have done projects already productive. Yeah, so during that time it was quite difficult to get from the proof of concept to a product use case, but we could handle it very early and we were already very early also fascinated from AI, and now it gets bigger and bigger and bigger.
And we will talk more about it. And Steve, tell us a little bit more about yourself and your company, AutoTools.
Yeah, sure. And just like Holger, I want to thank you for putting this together and look forward to seeing how this discussion goes. Yeah, as mentioned, I'm with AutoTool Inc. We're a robotic systems integrator that we do a lot of automotive work. We also do a lot of general industry work, mostly with joining and assembly systems. We also do some inspection systems as well. We do a lot, of course, we're in the Midwest. We're in the Columbus, Ohio area. So we're right there in the Midwest where automotive is pretty popular. We're also throughout the Southeast, Canada and Mexico too is where we put our systems. So we're on this panel, or I'm on this panel mainly to talk about how we're using AI to help our customers. We do some vision applications, some maintenance, some quality inspection, also some weld inspection applications where we're using some AI. So looking forward to this discussion.
Very good. Thanks for that introduction. Before we dive into it, let's talk a little bit about the problems we have in manufacturing. Can you name a few of them? Who wants to get started? Maybe.
Yeah, well, the problems we have in manufacturing is a diminishing workforce, and not only just a diminishing workforce for people just to load parts into cells, also a skilled workforce. So when it comes to taking care of equipment, maintaining robotic systems, maintaining automation systems, there's not as many people as there was years ago. So what kind of the way we look at it is we're not replacing people's jobs. We're putting automation in place for the people that our customers can't hire in the future, that the people that aren't there. So that's kind of what we're trying to do is help out with that diminishing workforce.
And Holger, where do you see particular problems in manufacturing?
So absolutely what Steve already said. Additionally, it's quite challenging. You have a lot of different machines, equipment in the production, and to get the data from every machine is a little bit different. So to have really an overview what is going on, I believe this is not so easy currently. Yeah, so this is something additionally I would like to add to it. But basically what Steve said with the workforce, it's really a very big topic. Also, we see it in Germany. We have this demographic change. In the next years, a lot of people will retire. So a lot of know-how will not be in the company. And the question is, what is the solution for that?
Yeah, and the solution, in my point of view, is all the different tools under the umbrella of digitalization, and AI is, of course, a big enabler there. What I see as issues, in addition, what you guys said, is all the different data silos we have in manufacturing. All the data is siloed in all the different systems on the PLC side, on the MES side, on the ERP side, on the SCADA side. Old machinery which is not connected. And I think the big magic of AI is to be able to connect this data silos and get the insights out of that. Where we already come into AI as an enabler, where do you see actually the big enablement of AI? Why can AI do all this magic? Who wants to hop first?
But I can hop in there. Well, the nice thing about AI is it's going to do some of the time-consuming tasks that it's taken engineers and operators a long time to do in the past. So I guess the first thing that comes to mind there is we're using it for vision pick-and-place applications. So bin pick has been a pretty popular idea in the industrial marketplace, but not many really put it in place to a large degree. So we're using a partner of ours, Apera AI, and what they can do is take a picture of the parts within a bin and let AI figure out how it's going to pick up those parts. So in the past, using vision systems, we would actually physically need to teach the robot as it picks up all of those parts. And then no doubt we would miss some of the possible orientations that part could be in. So AI is going to do millions of different variances on those parts. And then we take that data from AI, upload it to the robot. So we have very little teaching and debug to do. It may seem pretty basic, but the worst operator in a plant is still better than a robot, because a human could just grab a part out of a bin and immediately figure out the orientations it's in and then load it into a tool. Whereas with a robot, it's more time consuming. The camera has to figure out the orientation. The AI has to figure out the orientation. The robot has to pick it up. Sometimes we need to re-grip it to where we can re-grip it accurate enough to put it into either a machining center or into a welding fixture or whatever the next step of manufacturing is. So that's one popular way that we're seeing a lot of applications pop up. We're quoting it constantly to put in this vision AI bin pick or guided pick applications.
Yes, I'm familiar with Apera as well. I see also the opportunity that you actually can pick out of a box with unsorted parts, where in the past you had to have the parts in some type of palletizing, and somehow these parts have to get into it, where you have, again, manual labor involved, which nobody wants to do. So I see actually there the big advantage that you can take one part of your assembly process out by let AI with vision and the robot do the whole job. It's pretty cool. Holger, where do you see AI as a enabler in general first?
Yeah, in general, so of course there are a lot of different possibilities, a lot of use cases for AI. One very specific topic is knowledge management. Yeah, so when you start in a company and you are there in the production, of course you have a lot of questions. And what do you do normally then there? You ask someone, you ask your colleague, yeah. And let's say you have different colleagues there. Who do you ask? It's the colleague who has the longest time working in this area, who has a lot of knowledge about the machines, about the processes, about the customer, about the requirements. And when you know, okay, I can ask this person everything and he can help me, he can guide me, then this is the one you would exchange the phone numbers and talk to this person. And so basically from knowledge management perspective, you can combine everything together. Yeah, it's not only one topic, one knowledge. You can really use the information that is basically available as an expert working in manufacturing, but also the processes that you use inside of this company, and also the specific machines with the configurations with the software versions because it changes. Yeah, when you Google something and you want to change something, you have to enter which version do you have and stuff like that. And when you combine really everything together, you have a very holistic approach from the knowledge management perspective, which gives you a lot of possibilities. And if you give this in the hands of the people, then you immediately have higher skilled people working in manufacturing. And this is what I believe is one very, very nice topic.
Fully agree on that. And I would shorten it down to get your people in the field the information they need at the location they are in order to do their job right. And I forgot, on the device which they carry already with them, a phone or a tablet, so that it's easy, intuitive, and valuable. Would you agree on that?
Yeah, absolutely. I mean, it must be as simple as writing a friend a text message and saying, okay, I have here an issue. Well, what would you do? Yeah, how can I have something with the porosity of my welding seams? What should I do specifically? And a lot of different possibilities really to gain knowledge from the company already inside, but also to leverage it with the knowledge outside of the company without giving your insights away. Yeah, really to combine it. There's a lot of huge potential in it. Yeah.
Let's jump right into a use case, and it seems that you guys at SULZER did already something like that. Can you give us a little bit more details and what was that whole scope of work and what was at the end actually achieved?
So basically, we call it CACC. CACC is an acronym for Complete AI Project Specialist, and it combines all the information that you need, as you mentioned, Markus. And what we do is we take from an item in the manufacturing all the information like the dimensions, the porosity of the welding seams, the holes, all the data. We analyze it and give live feedback. Is everything okay from the quality perspective? Is there something increasing, like the porosity I mentioned? Give it back, and then giving the people, the workforce in the production, the possibility to act before the quality gets too bad. This is basically the case. And as you mentioned, Markus, a very easy, intuitive way when the person doesn't know what to do, right? Yeah, that you guide them what he should actually do, so that that your quality stays on a high level. Yeah, that you always get good quality out of the system. Yeah.
As we're talking here about a specific welding application, one of the general questions is always, how does the data get into the AI that the AI can do something? So in this particular case where the welding is inspected, how is the inspection done? Is there the person on site taking a picture with its phone, or is there a specific measurement system? Can you further elaborate how it works in this particular use case?
Yeah, so I can do it, or Steve, you could also do it.
Or Steve wants to jump into that. Yep.
Yeah, so we're partnering with SULZER on this. Of course, they have the AI software that we're going to use. So we use a profiling scanner that is going to basically scan the entire weld. And when we scan the entire weld, we're going to look for the size of the weld. We're going to measure the weld. We're going to look for any cracks and porosity. And then once we scan that entire weld, we're going to inform the AI or the complete system. In this case, we have a PLC and HMI, and then we have the AI software that is kept on the cloud. So we're going to inform all of our system, both the AI and our PLC, what is wrong with that weld. All right. And so then the AI system is going to analyze that data and give feedback back to the operator or the maintenance person on how they can fix that weld. So first we're going to say whether or not the weld is good or bad. And then if it's bad, we're going to tell them what they need to look at to go back and fix that weld. Now, sometimes that could be a little it could be a difficult answer if there's gapping in the parts, meaning, we have more than, we're not directly connected between the two parts that we're welding. Sometimes we're going to have to put in there of how they need to go back and fix their welding fixtures. So that's going to require a long-term loop of information where us, the integrator, is feeding that AI system proper information on how to fix everything to where they can get a good result.
And my understanding of this particular use case is that in the past, there were kind of similar systems, but they only did a good, bad definition of it. And with the addition of bringing AI to the game, in case it's not okay, AI is also able to determine what is actually wrong and how to fix it. Is that correct?
Yep, that is correct.
This is correct, and it's really an holistic approach. So it's not only that you check your current production and can then correct or take action to correct something. It's also that you can very easy access the data that is then already stored. So you can just ask, okay, how many welding issues did I have had in the last month, let's say that way, yeah? So that you get a better understanding of the data that you have and can use it in the future for your production. Yeah, it's really a combination for a lot of different topics for a lot of different people inside of the company.
Yeah. And with using actual data and historic data, my understanding is there's always a way of self-learning and adapting to changing parameters in manufacturing to still make it good.
Yeah, you can see trends, yeah, and can see, okay, patterns, why specific issues happened, and then it's always to increase the quality before something happens, let's say that way. Yeah.
So find an issue before it gets really bad.
Before it gets really bad, exactly, to identify, okay, there will be an issue in 2 hours if you don't make anything, yeah. Take action right now, and so this is one of the topics. Yeah.
And just to get the big picture together, Steve, you guys with AutoTools make the robot cells with the welding application, and in this particular use case, you guys partner with SULZER, which do the AI part of it, and then you bring it together and sell it and offer it as a general solution to you guys' customer.
Yeah, that is correct. So, of course, we'll do the weld line. At the end of the line, we'll produce a welded assembly. And then our partnership with SULZER is here is we're going to take that assembly, inspect it. We're going to inspect it dimensionally. And then we're also going to inspect the welds and then give our customers that feedback. And many of our customers already require inspection at the end of the line. If it's a critical component in a vehicle, they have to measure it and give their customer a data report. So we're going to take that data report a step further and give them feedback on how to fix the welding and how to fix it dimensionally.
Yeah, which is an important part in manufacturing, as you subsequently put parts together and you want to define an error as early as possible. Otherwise, this welded part, a body part or something gets into, for example, final assembly. And then at that point of time, it's figured out it doesn't work or fit together. And then the cost of correcting that error is way higher.
Yep, correct.
Very good. So we have now Vision AI as a use case. We have Welding AI as a use case. What other use cases of AI do you guys see in manufacturing? Another topic?
We could talk a little bit more about the maintenance.
That's a good topic.
On it a little bit. So kind of what we're seeing too with that diminishing workforce, many times in manufacturing, something happens on an assembly line, a robotic assembly line, and the line stops. Many times these could be very basic stoppages that are not difficult to recover from. Maybe there's a turntable that's turning, the light curtain is broke, and then the cell stops. And now the operator has to get it running back in auto. So how do you do that? Well, many times at our customers, the operators just call maintenance, and it may take maintenance 15 minutes to get to that cell, 20 minutes, a half hour, depending on how busy they are, and that cell is not running production. So what we're trying to do by partnering with SULZER is let's enable these operators to be able to do some of this maintenance on their own. So how we're going to do that is with maintenance AI. And as you mentioned earlier, Marcus, it's using something they already have on their person, a phone, a tablet, to where we're going to put how to troubleshoot that cell in that tablet. So some of those items could be general maintenance on the cell, how do you replace welding tips on a spot welding gun, or it could be how to get the cell back in auto. All of that we have to work together with SULZER on to make sure that that AI database has the answers to those questions, and that when we search for it, it's going to pop up. So it does take a lot of effort on the front end, but the back end to it at the end of the day is an increased operating efficiency for our customers. So Holger and I are looking for opportunities with customers to give them this technology.
That's really a great application. And my specific question to you, Holger, is how do you actually get the data and the information in how particular work steps or work processes are done? What do you use as a data source?
Basically, there are different data sources that we use. I mean, you use, first of all, of course, the documentation from the producer of the machine, but you leverage it also with lessons learned from inside of the company. And what you can also do is to connect to specific data sources in the internet. There are a lot of people exchanging why some things are not working and so on. So you have really a lot of different information that you use here, you combine it, and then you can provide us. And I would like to mention a little story that I recently heard.
Please do.
So basically, there was a stop in the production line and nobody could fix it. And then they called someone outside with a helicopter. So that took a little bit time. The person flew in with the helicopter. Then he walked to the machine. He fixed it quite quickly. And then he said, yeah, it's a common issue. And then he flew away. And this is what I think you can really give these kind of tasks people inside of the production. Yeah, that when they know what to do, that you provide them very easily the information. And also in the workforce, you have different languages. And this is one of the strengths of AI, of course, that you can provide it in every mother language that a person needs. And it doesn't matter what the data sources are, which you have given to the AI. When it was English and the person speaks another language, it's no issue. And he can really get all the information step by step with the pictures to provide him a guidance what to do there.
Yeah, so it's kind of like a multi-purpose tool which solves a lot of issue we have in manufacturing. From the different data silos, information is scattered, and we're talking all different languages on the shop floor, specifically in an immigration country like the United States, where you have people oftentimes from all over the world where English, for example, is not the first language.
Correct.
What other applications you have in mind? Maybe, Steve, you have another one?
Yeah, we've been doing some weld path AI.
How does that differentiate from the previous example we mentioned?
Well, in this case, it's we're doing it in process. So there's a couple ways to go at it. One is you generally know what you're welding. And the problem is, and this comes into play when you're looking at heavy equipment, and that is, where is your weld seam going to be? In automotive, our tooling kind of guarantees where that seam's going to be, but in heavy equipment, that seam could be plus or minus 4 to 5 millimeters. So in that case, you're going to teach it generally, but then you have to find it. So we're using cameras on the robot combined with touch sensing to look and find that seam. And once we find that seam with the camera gets you in the ballpark, the touch sensing gets you on the money. is the way to look at it. So the camera is not accurate enough for MIG welding yet, but it's heading in that direction. So it's going to take a picture of the scene, get us real close. Then we're going to do the touch sensing to find that scene. And then we're going to do through arc touch sensing as we continue down that weld to make sure we stay on track or on the scene throughout the welding. So the software combination between the camera and the robot there is really the magic that helps us. And that's AI that's doing some of that. So that's one way that it's getting done. And another way to do it is, and this is more CAD to path, there's a few companies out there where you can save a lot of time on the teaching by uploading your part, picking the weld seams, and just let the software figure it out. So then you upload that program to the robot, and it goes and does the welding, and it's going to do the same thing, use a camera and the touch sensing, and complete the welding. So we're seeing some of that. There's a couple of companies out there that do that. One of them is Apogee, and they use that combination of the camera, the touch sensing, and they have the AI software that is going to do that for you. They're a partner of ours.
So just to sum it up, two different applications in how to inspect a weld. Example number one is you do the weld and then afterwards inspect it and analyze it. And in your last example, Steve, you actually do the analytics while the welding is happening and adapt the set points to it during that process.
Yep, that's correct.
One of the issues we have in manufacturing is that people are not ready for AI yet, as this is all new and embarking. What are some good ways to prepare workforce for artificial intelligence in manufacturing? Do you have any examples or use cases what you guys did with your people?
So basically, I don't believe that you need to prepare them specifically to AI. So the solution must be as simple as possible, and at the end, no one cares if it's AI or not AI. Yeah. For example, Amazon, we all used AI there already. Other customers bought also this and this product. So if you give them the possibility to use a technology which they can very easily have a benefit from it. And Markus, you mentioned it in the beginning. Yes, very intuitive. You get very good information out of it. And with the intuitive solution, you don't need to train them specifically. I don't want to have very complicated tools that are for professionals, whatever. It must be very easy. And basically what you can do is you look what for tools they currently use. When you have a mobile phone, everyone knows how to send a text message to a friend. Mm-hmm. In a business case, you have maybe Microsoft Teams and you know how to chat in Microsoft Teams. So bring the solution inside of the tools the people already use, yeah, and make it very simple, very intuitive for them. And then it's really no issue. You don't need trainings or something like that. You can just say, okay, this is like a colleague. You can ask him 24/7, whatever you want, and he will he will support you and give you all the answers that you need.
Very good. How do you see the thing, Steve?
Well, Holger hit the nail on the head there. Once the AI is implemented, it has to be simple to use. Otherwise, it's not going to be used. That's why the effort on the front end is so key. So I know internally what we've done here is to get the AI set up properly. We're taking champions of people who really believe in it to be a part of that setup process. If they're already using it in their daily life, they're going to be bought in already to getting it set up. And then once it's set up and they're using it, hopefully by that point, it is simple enough for everyone to use. And that's kind of what we've got. We've done it on some simplistic internal processes. And then, of course, we're working with SULZER to do the custom manufacturing solutions as well. And that setup is key to get it to that point where it is simple to use.
That is a good summary, as AI can be a good tool to make manufacturing better, faster, and more efficient.
Yeah, right.
Yes, very good.
All right. Thank you for joining to this session of the DigitalituM podcast at the intersection of manufacturing and digital transformation. Don't forget to follow the podcast, like it, and comment it on the podcast platform of your choice. Thank you all.
Thank you.
Yeah. Thanks, Markus. Thanks, Holger.
Thank you, Markus. Thank you.